We are looking at indices today in mathematics. Indices. Now, when you have x raised to power y, this x is called the base, and this y is called the power or exponent or index. So meaning that if I have 2 raised to power 5, this 2 is the base and this 5 is the power. So this is the base and this is the power. So this is 2 raised to power 5. If I have this, 8 raised to power 3. Okay, now we are going to look at laws of indices. What are the laws that are guiding numbers that has to do with power, exponents, or base? Okay, laws of indices. Now the laws of indices, we have law 1. Law 1 says if I have x raised to power a times x raised to power b. Now because they have the same base, I'll pick one of the bases, then and subtract the power. I'll add the power rather, a plus b. A plus b. So e.g., if I have 2 raised to power 3 times 2 raised to power 2. Now you can see that they have the same base. So pick one of the bases and add the power 3 plus 2. And that will be 2 raised to power 5. And if you like, you can still re-express it. 2 raised to power 5 means 2 in 5 places. 2 times 2 times 2 times 2 times 2. Now, the second law, law 2, is saying if I have x raised to power a divided by x raised to power b, I will pick one of the bases and subtract the power. You see that? Pick one of the bases and subtract the power. E.g., if I have 4 raised to power 5 divided by 4 raised to power 3, because they have the same base, pick one of the bases and subtract the power. 5 minus 3. So that will be 4 raised to power 2. And of course, 4 raised to power 2 means 4 times 4, which is 16. Now, law 3 is saying that anything raised to power 0 is 1. Anything raised to power 0 is 1. So if I have 1000 raised to power 0 is 1. 8 raised to power 0 is 1. Anything raised to power 0 is 1. Then law 4 is saying if I have x raised to power minus a, look at this, x raised to power minus a. Now I can say let this minus change to 1 over. You know, if this minus change to 1 over, this is what I'll be left with. Just bring this under it, x raised to power a. You see that? So e.g., if I have 2 raised to power minus 3, so it's the same thing as say 1 all over, then the 2 raised to power what? 3. And of course, 2 raised to power 3 means 2 in 3 places. So, and that will give you 1 over 8. Don't forget, 2 raised to power 3 does not mean 2 times 3. So, let's look at law 5. That's law 4. Law 5. Law 5 is saying that if I have x raised to power a over b, look at this. Now I will change this to square root. This line will change to square root. Then the x will come inside. Then the b will come here. Then the a which is on top will be here. It's a law. The x will come in the square. The line will change to square root. The x will come inside. B will be here, and A will go up. So look at how to apply that. Let's say, for example, that I have 8 raised to power 2 over 3. That will now be square root. This line will change to root. 8 will come inside. Put the 3 here, and then put the 2 on top. So here it's like saying, what's the cube root of 8? Cube root of 8 means what 3 numbers are the same, that when I multiply it, it will give me 8. What 3 numbers are the same, that when I multiply it, it will give me 8? It is 2. Then raised to power 2. It is 2 that I will multiply 3 times, that will give me 8. 2 times 2 is 4, times 2 is 8. So 2 raised to power 2 now means 2 times 2. And of course, the final answer will be what? Will be 4. Now, let's look at law 6. Law 6. Law 6 is saying that if I have x raised to power minus a over b, look at this, minus a over b, the minus will change to 1 over, this line will change to square root, the x will come in, the b will come down, and the a will go up. So I'm now going to have this. Let's take an example on that. Now the example on that is that if I have 8 raised to power minus 2 over 3, so the minus will change to 1 over, then this line will change to root of 8, then the 3 will come in, then raised to power 2. So I'm going to have 1 all over. What's the cube root of 8? Like I said the other time, is 2 raised to power this 2. And of course, that's 1 over 4. And the last law, but not the least, because there are 7 basic laws of indices. And the last one is if you have x raised to power a into bracket b, so bracket will change to times. So you are going to have xa times b, and that will be xab. You see that? So meaning that if I have 2 raised to power 3 into bracket 2, so it will become 2 raised to power 3 times 2, and that becomes 2 raised to power 6. The bracket will change to times. And 2 raised to power 6 does not mean 2 times 6. It means 2 times 2 times 2 times 2 times 2 times 2. 2 in 6 places. And of course, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is what? 64. That's your final answer. So those are the basic laws of indices. Now let's look at how to apply these laws to solving questions. So I'm going to give some set of questions, and then we are going to apply law of indices to trash those questions. Now, looking at these following questions, number 1, number 2, So let's try these 10 questions, and then by solving these 10 questions, you will have a full grasp of what indices is all about. And of course, we are going to be applying the 7 laws I've given to us the other time. Okay, now look at the first one. Question 1, you have 25 raised to power 1 over 2. Now I told you, when you see something like this, what do? This line will change to square root, and then the 25 will come inside. And of course, what is the square root of 25? The square root of 25 is 5. That is, what 2 numbers can you multiply? 2 will be here, and then you put 1 here. So the square root of 25 is 5. That is, what 2 numbers can you multiply that will give you 5? Then number 2, you have 9 1 over 6 times 9 1 over 3. Of course, this is the law of indices, first law. So because they have the same denominator, pick one of the denominators and add the numerator. So 1 over 6 plus 1 over 3. Now, and if we check our previous class on fraction, I have told you how to add fractions. So as you have 1 over 6 and 1 over 3, now you can show the workings here. 1 over 6 plus 1 over 3. The LCM is 6. 6 can go in 6, 3 can go in 6. So 6 in 6 is 1. 1 times 1 is 1. Plus 3 in 6 is 2. 2 times 1 is 2. So 1 plus 2 is 3 over 6. And of course, 3 over 6 is 1 over 3. 1 over 3. 1 over 2 rather. That is 3 here 1, 3 in 6, 2. So it means that this is the same thing as 9 whole number 1 over 2. And using the law of indices, this will turn to square root of 9. So your answer is going to be 3. Don't forget, this can be plus or minus 3. Plus or minus 5. So you see that number 3. How do you solve that? You have 2 raised to power 6 divided by 2 raised to power minus 6. So pick one of the bases because they are the same. Anytime you have divide, you always subtract. So it will be 6 minus. Don't forget, the divide is what is changing to minus. This 6 is having its own minus. So you are going to have minus 6 like this. The first minus is the divide, and the other minus is this. So you are going to have 2, then minus times minus, bracket means times, minus times minus is plus. So you have 6 plus 6, and that becomes 2 raised to power what? 12. Then number 4, you have 2 raised to power 3 into bracket minus 2. This is another law of indices. How do you solve this? You open up the bracket by multiplying. So it becomes 3 times minus 2. The bracket will open, you multiply the power 3 times minus 2. 3 times minus 2 will give you minus 6. And of course, you can apply the law of indices. This minus will change to 1 over, then you bring the 6 to 2, 2 raised to power 6. So that's how to take care of that. Then the next one is 27 raised to power 1 over 3. That's number 5. 27 raised to power 1 over 3. Now, how do you do this? I told you this one will change to roots. The 27 will come, then 3 will come inside. Because I have 1 here, I'll just put 1 on top. Now, this means cube root of 27. Cube root of 27 means what 3 numbers are the same, that when I multiply it, it will give me 27. 3 times 3, 9. 9 times 3, 27. So 3 is the answer to this. Then, question 6. Question 6, which I would like to use this part because I've solved all the question at that part. So let me use that part to take question. Okay, I can even go with this. Now, question 6 is 81 all over 16 into minus 3 over 4. Now, how do you do this? This minus will change to 1 over, then this line will change to square root. The 81 will come inside, the 16 will come inside. Because I have 4 here, bring the 4 inside. Then I have 3 on top here, bring the 3 here. You see that? We are still applying law of indices. And here, I'm going to have 1 all over 4th root of 81. Means what 4 numbers are the same, that when I multiply it, it will give me 81. What 4 numbers are the same, that when I multiply it, it will give me 81. It is 3. Because if I say 3 times 3 is 9, times 3 is 27, times 3 is 81. So you can see that I multiplied 3 4 times to give me 81. So I will have 3 all over. Then this 16 means what 4 numbers will I multiply that are the same, that will give me 16. Of course, that is 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So the same number that I will multiply 4 times is 2. I'll write it. And because I have 3 here, put 3 on top. So here now I have 1 over 3 in 3 places is 27. Over 2 in 3 places is 8. And this is the same thing as say 1 divided by 27 over 8. So in mathematics, you can now say 1, this divide will change to times. 8 will go up, 27 will come down. Once this divide change to times, so you have 1 times 8, that's 8, over what? 27. That's the answer to that. Okay, let's look at question 7. This is question 6. Now question 7, I have cube root of 4 raised to the power 1.5. Now if you look at this, 1.5, I told you how to convert decimal to fraction in the previous video, previous class. So 1.5 is the same thing as 15 over 10. That is, write the numbers together. How many numbers do I have after the point? 1 number, so write 1 0. Now, what can go in the 2? 5 can go in 2 to give you 3. 5 can go in 10 to give you 2. So that means I can rewrite this as cube root of 4 raised to the power 3 over 2. So that is the meaning of this. And of course, this can later be converted to 4 3 over 2 raised to power 1 over 3. It is this root 3 that has changed to 1 over 3. Now you must have an understanding that if I have x into root of 2, is the same thing as x raised to power half. If I have cube root into x, is the same thing as x raised to power 1 over 3. You must have that understanding. So with this understanding, I came about it. So here, 3 can cancel 3. So I am going to be left with 4 raised to power 1 over 2. That is this one and this 2 that is inside. So I am going to now have square root of 4. And what is the square root of 4? The answer is what? 2. That's how to trash that. And of course, number 8. Number 8, you have 0.09 1 over 2. Now, how do you convert decimal to fraction? I treated that in my last class. Now 0.09 is the same thing as 9 over 100. That is two numbers after the point. Then raised to power half. Don't forget. And in law of indices, this one will change to square root of 9 over 100. So there may not be need for you to be writing these two here. So what is the square root of 9? It is 3. What is the square root of 100? It is 10 raised to power 1. Since 3 raised to power 1 is 3, 10 raised to power 1 is 10. So the final answer is 3 over 10. Now let's solve number 9 question. Number 9 question, you have 9x minus 3 times 9 times 2x raised to power 5. You look at this. Now you will see that in this one, you can first pick your 9 and 2, bring them together. 9 times 2 is 18. Then this x, they are the same. You pick one of it. And because it's times, you will add the power. Minus 3 plus 5. You see that? 9 times 2 is 18. Then x raised to power minus 3. You pick one of the x, one of the bases, law of indices, and then add the power. Now this one will now give you x raised to power x minus 3 plus 5 is 2. Minus 3 plus 5 is 2. That is, you are owing 3 and you have 5. If you pay the 3, you will be left with 2. And of course, the last but not the least for indices, which is number 10 question. Number 10 question is 2a raised to power minus 2 times 5a. Now if you look at this one, this minus 2 is affecting both the 2 and the a. It's not like this one. Minus 3 is only affecting the x. So in this one now, this is as good as saying 2 raised to power minus 2 times a raised to power minus 2. You are giving this minus 2 to both of them. Then times 5a. Or I can write it as times 5 times a. Because 5 times a will give me 5a. Now this 2 raised to power minus 2 is the same thing as 1 all over 2 raised to power 2 times this one is the same thing as 1 all over a raised to power 2. This minus will change to 1 over, then the a2 will come under it, times 5 times a. So with this, you can now say 1 over 2 raised to power 2 is 4 times 1 all over a squared times 5 times a. So with this, I can decide to say 1 times 5, 1 times 1 times 5 times a, that is 5a, over 4 times a squared, that is 4a squared. Now with this now, this is the same thing as 5 times a, this is the same thing as 4 times a, because it is a squared. So a will cancel 1a. So my final answer will be 5 over 4a. And that's your final answer. You can't do anything to that. So with this, we have come to the end of indices.